Hello, my dear students, and welcome back. I know, exams are right around the corner, and the tension is probably building up, isn't it? But don't you worry. Today, let's forget all that stress and just have some fun with a little bit of math. Magic!
You know that chapter, Playing with Numbers? Sometimes it can feel more like numbers playing with us, right? All those questions about factors and multiples and remainders, they can be really confusing. But what if I told you there are secret tricks to solve them in just a few seconds?
That's right. Don't worry, Beta. Your teacher is here to turn you into a maths magician. In this quick explainer, we're going to learn some amazing tricks that will make you look at numbers in a totally new way. I promise. Okay, are you ready for our very first magic trick? We are going to uncover a hidden secret about numbers that follow each other. Get ready to be amazed. It's really simple. Just take any four numbers that come one after the other, like 3, 4, 5, and 6. Now let's just mix them up with some plus and minus signs, like you see here. 3 plus 4 minus 5 plus 6. What do you think the answer will be? Any guesses? And the answer is 8. Now, what's interesting here is that 8 is an even number. Do you think that's just a coincidence? Or is there some real magic happening here? Let's find out. Okay, one time could be just luck, right? Let's test it. Let's try with 5, 6, 7, 8. And look, the answer is minus 16. That's still an even number. Okay, let's go back to our first numbers but change the signs. We get 6, still even. You see, this is not a coincidence, Beta. It's a rule. The answer is always an even number. So what's the secret behind the trick? It's a simple idea called parity. Now, that's just a fancy word for asking, hey, is this number even or odd? That's it. And the rule is, when you take 4 consecutive numbers and add or subtract them in any way you want, the parity, whether it's even or odd, will always be the same. In this case, always even. That's not magic, it's just pure, beautiful mathematics. All right, trick number 1 was fun, wasn't it? Now, for my next act, I am going to give you some actual math superpowers. These are the divisibility rules that will help you solve huge problems in your exam without any of that long, boring calculation.
First up, the superpower of 9. How do you know if a huge number, let's say 7 crore, 42 lakh, something, is divisible by 9? It's so simple. Just add up all its digits. If that small sum you get is divisible by 9, then the whole giant number is divisible by 9 too. But why does this shortcut work? It's not magic, it's just really clever. Look here. Think about it. 10 is just 9 plus 1. 100 is just 99 plus 1. 1,000 is just 999 plus 1. You see the pattern, right? All those 9s, 9, 99, 999, they're obviously divisible by 9. So the only things left over are those extra 1s. And when you add up all those leftover 1s, what do you get? You get the sum of the digits. It's so cool. And you know the best part? The rule for 3 works exactly the same way. It's like the little brother of the rule of 9. Just sum up the digits, and if that sum is divisible by 3, the original number is 2. It's like a buy one, get one free offer. So easy to remember. Now for a really cool one, the rule of 11. This one's a little different. It's like a little dance. You add up the digits in the odd positions, the first, the third, the fifth, and so on. Then you add up the digits in the even positions. Finally, just find the difference between those two sums. If that answer is 0 or 11 or 22, basically any multiple of 11, then bingo, the whole number is divisible by 11. Okay, you have your new superpowers, but, every superhero needs to train, right? So let's build your confidence by trying them out on the kind of tricky questions that teachers just love to put in exams. Ooh, here's a classic exam trap. I have seen so many students make a mistake with this one. Read it carefully. If a number can be divided by 6, and it can also be divided by 4, does that mean it must be divisible by 24? Pause for a moment and think. Always, sometimes, or never?
The answer is sometimes true, and that's why it's a trap. See, this divisibility rule only works if the two numbers are coprime. That's a fancy term that just means they don't share any common factors other than 1. But think about 6 and 4. They're both divisible by 2, so they aren't coprime. The lowest common multiple of 6 and 4 is actually 12. For 24, you need to use coprime factors like 3 and 8. So here's your big exam tip. To check for 24, you must check for divisibility by 3 and 8, not 6 and 4. Remember that.
Okay, let's try another common question. What kind of number always leaves a remainder of 3 when you divide it by 5? The hint is to just think about the 5 times table. 5, 10, 15, 20, and so on. How can you get a remainder of 3 from those?
Of course, you just add 3. So 5 plus 3 gives you 8. 10 plus 3 is 13. 15 plus 3 is 18. All of these, when you divide them by 5, will give a remainder of 3. And in algebra, we can write this simple rule as 5k plus 3. This little expression represents every single number in the universe that fits this rule. And there you have it. You've learned the secrets, you've mastered the logic, and you now have actual mathematical superpowers. You are officially a number master. It's time to own it. So, let's quickly recap your new magic toolkit. You have the even number secret, you have this super easy digit sum superpowers for 9 and 3, and you have that cool little alternating dance for 11. Remember these and you'll be unstoppable.
Now, before you go, I have one final challenge, a test to see if my clever students are truly ready for their exams. Look at this happy little pot with his pebbles. He has a puzzle for you.
Listen carefully to his riddle. When I group my pebbles in 3s, 1 stays. When I group them by 2, 1 stays. When I group them by 5, 1 stays. But grouping by 7, perfection is found. How many pebbles do I hold? Aha! This is a classic remainder problem, isn't it? It brings together everything we've talked about. I have full confidence that you can solve this. Use your new knowledge about multiples and remainders and post your answer in the comments below. I can't wait to see your amazing work. All the very best for your exams, my dear students. You are going to do great.